So our recording starts now. So just so that I have this at the beginning of the recording, today is the calculator workshop for the SAT, and we are covering section 4 from practice test 10. We just went over how to use the calculator for solving systems of equations. We use the TI-84 plus CE first, and now we are using the TI-84 plus. So we have the exact same answer here, that x equals -0.5. Just because I was not recording earlier, let me quit out of this and switch back really quickly to the other model here. So the TI-84 plus CE, we still just went to apps and then down to Polysmelt, simultaneous equation solver, 2 equations, 2 unknowns, press graph for next, filled in our coefficients, pressing enter after each one, and then to solve it, we pressed graph. So the exact same thing. And even though I wasn't recording earlier, this luckily was the first question we looked at today. So that's a good catch. Let's see here. I am going to grab another kind of surprising calculator question. Let's see here. I'm gonna grab it before we look. Let's look at number 19. So we're kind of in this vicinity of something we could solve in our calculator that maybe you wouldn't think you could. So in the equation above, A is a constant, the graph of the equation in the XY plane is a parabola. Which of the following is true about the parabola? Who can tell me what I could do in the calculator to solve this question for number 19? So just send it to me in the chat box, what you think I should do here. And I'm gonna give you guys a couple seconds to come up with your solutions. How do you think we should solve that one? For number 19, what would be your approach if you used your calculator? Of course, you should really know your core concepts. So you should, if you've been studying for the SAT, and this is in that email that I already sent out, and it will be in your follow-up email too, you should know here the parabolas from the core concepts. That this parabola that they gave us right here is in vertex form. There's a negative leading coefficient. So let's see here, a negative leading coefficient. This parabola opens down, so there has to be a maximum. So it has to be C or D. And our maximum, or our vertex, occurs at HK. So we need to flip the sign of what's inside of parentheses and leave the sign alone for what's outside of parentheses. So our maximum would occur at +3, A. But let's say you drew a blank on test day, or you haven't been studying your core concepts, and we just wanted to use our graphing calculator to solve this. Somebody said you could graph the equation. Sydney said that, and that's what I would use for this. I don't usually use the Connix apps on the SAT. In fact, I've never used it on the SAT other than for circles. I never use it for parabolas. So here we go. We are going to just graph this, but I have a problem. I can't put A in here, so I'm going to have to pick a number for A. And I like picking small numbers other than 1. So I'm just gonna say A is 2 for the sake of graphing here. And I knew that I could pick a number because all of my answer choices have that constant A in there. So that tells me that I can just pick a number for A and then back solve. So I'm going to graph this, and I can see, yes, this parabola opens down, so there needs to be a maximum. It has to be C or D. And then I can calculate my vertex by going second trace. Do you see how the calc button is in blue? So that's how I know I needed to press second and then trace to access the calculate feature. And then we're just going to scroll down to maximum, and it's going to ask us left bound, and I'm going to press enter. And then it's going to ask me right bound, and I'm going to press enter. And then I'm gonna go up to the vertex, and it gives me my maximum is at positive 3, 2, right? When x is 3, y is 2. And that is only for answer choice D, because remember we said A equals 2. So easy way to get to the right answer there, just using our calculator. Doesn't mean we're always going to use our calculator, but for questions like that, I really would. Let's see another one. I'm going to check if there's any more questions that I want to look at for the calculator before we move on to some calculator section questions that we don't necessarily need to use the calculator for. Let's look at number 36 while we are looking at graphing. And this is kind of a challenging question. A lot of students have been stumped by this. So I'm going to give you just a couple of seconds to read it through and think it through before I spoil it and I tell you what you should do for this question. So it says, in the XY plane, a line that has the equation y equals c for some constant c intersects a parabola at exactly 1 point. If the parabola has the equation y equals negative x squared plus 5x, what is the value of c? Let's just think it through. Okay, so you shouldn't really have to put your pencil to paper for this question that much. The first thing that I would want you to do is to draw a horizontal line for y equals c, because that's y equal to a number, so it would just be a horizontal line. And then that horizontal line is going to intersect this parabola, and this parabola also happens to open down at only 1 point. If I put that horizontal line down here, it would intersect that parabola twice. So it can't be down there. If I move it up a little bit, it would still intersect it twice. So it's going to have to be right there at the vertex of that parabola for my y equals c, for that y equals c line. So I'm going to go back to y equals, and I'm going to graph this new parabola, negative x squared plus 5x. And this is a core concept that when you read on the SAT in the XY plane, you're going to graph. It's on the first page of the math core concepts. When you see XY plane, graph, and that's why we would graph this. Luckily, we are in the calculator section, so we can just use our calculator to graph. If you do not have a graphing calculator, you could also graph this by hand. The calculator just saves time. So we have that right there. And again, we're just going to calculate the vertex. So we're going to press second trace and find the maximum. So left bound, and then right bound, and then go back to the vertex. And it gives us our maximum occurs when x is 2.5 and y is 6.25. And we want c and y is equal to c, so we need our y value. So the answer to this question would be y equals 6.25. I hope everyone was able to follow along for that question. Okay, let me grab just 1 or 2 more calculator questions, and then we're putting the calculator away. Okay, this will be our last super calculator question for today, because I definitely want everyone to know how to use this feature. And I'm not going to tell you yet. I'm going to have you think through and tell me in the chat which feature you would use to solve this question. We're going to go to question number 21. So let's read it through. And if you already recognize this question or you know what you would use, just send it to me in the chat. Or as I'm reading through it, you can send it. So they give us an equation there, and then it says Clayton will mix X milliliters of a 10% by mass saline solution with Y milliliters of a 20% by mass saline solution in order to create an 18% by mass saline solution. The equation above represents the situation. If Clayton uses 100 milliliters of the 20% by mass saline solution, how many milliliters of the 10% by mass saline solution must he use? Let's see here. Someone asked, Catherine asked, how did you get the vertex? I was able to get the maximum on right bound and left bound, but I can't figure out how you got the vertex. So the vertex is the maximum in this case. So while you guys are thinking through this question, let's just circle back here. My maximum is the vertex. So if I go second trace and then maximum, and it says left bound, we're going to the left, and then we're going to the right, and then it says to guess, and we want our cursor right around our maximum there, or our vertex, and press enter, and then it gives the maximum. Does anybody know what we would use in the calculator to solve number 21 here? Give you guys a second. So we would actually use equation solver or a numeric solver. So they say if Clayton uses 100 milliliters of the 20% by mass solution, so should we plug in 100 for the X or for the Y? Who can tell me that? Should we plug in 100 for X or Y? If he is using 100 milliliters of the 20%. Yes, the Y, Maria. So we want to go to math, and then we're just going to press up one. And this is a special feature of this calculator. So we're going to go to Numeric Solver, and then I'm just going to put in the left-hand side of the equation in the first box, which I have here. So 0.1x plus 0.2 times 100, because remember, we're plugging in the 100 for Y. And then the second box, I have 0.18 times x plus 100, because again, we're plugging in the 100 for Y. And then you would press enter for OK and graph to solve it. And it gives us x equals 25. So this can solve any equation for you. So 21, the answer would be B. Another way that you can use to solve any equation on the calculator section. So this particular question isn't in this calculator section, but I just want you to kind of have an idea how to solve it. So actually, let's use this one. We could also treat the left-hand side of the equation as y1 and the right-hand side of the equation as y2. So I could say 0.1x plus 0.2 times 100 is y1. And then for y2, think of that as our second box, basically. We have 0.18 times x plus 100. And we're just going to graph that, and it graphs two lines. And the intersection of the two lines is our solution. And we are trying to find x here, right? So we're just going to go second trace and then go down to intersect. And it's going to say the first curve, second curve, and then we want to kind of guess that point. I'm going to press enter, and our intersection occurs when x equals 25. So our answer here would be B. And as fancy as we can get with using the calculator, the number one thing, or I'll probably retract that at some point. One of the top things, let's put it that way, one of the top things that you need to know your calculator can do on the SAT is that you can graph each side of an equation as y equals and then find the intersection to get the solution. That is incredibly useful, especially when you get trickier equations on the SAT. Okay, I am going to hop on back here into test 10 where I can actually write on it. So we're gonna put the calculator away, at least for now, not forever, but at least for now. Let me share my screen here again. Okay, so starting out, remember, it's going to be easy, medium, and hard for SAT math questions, and they kind of go in order, but we don't want to just dismiss those easier questions as, oh, that is so easy. I'm not going to worry about it. So for number 1 here, who can identify the concept as that is the concept for number 1? What are they testing you on for number 1? And I'm going to look in the chat box. And that is really key for the SAT, is to be able to identify quickly, not just what the right answer is, what concept category the question fits under. So I have 1 response. I'm going to see if anybody else knows. I got another response. Let's see here. Y equals mx plus b. Great, you guys. So 3 people got this. This is just a y equals mx plus b question. And I could tell that this is a y equals mx plus b question without even reading the question, because all of these answer choices are in the y equals mx plus b form. It's really helpful to just glance at the answer choices on the math section before you read a word problem, so you kind of have an idea what you're looking for. In this case, as we read the word problem, we need to watch out for the y-intercept and the slope. So when we see here that it is initially hovering, that is our starting point, right? So 40 feet is our y-intercept. But that is not super helpful to us here, because most of these have a y-intercept of 40, right? Only answer choice D has that 21, so it can't be D, but we still don't know, is it A, B, or C? And then they say it begins to gain altitude at a rate of 21 feet per second. So that 21 feet per second is our slope. So we want a positive 21 next to our variable, which only occurs for answer choice B. I want you to think critically even through the easier questions, and y equals mx plus b is one of the most important concepts that will occur on the SAT. If you don't know y equals mx plus b, you are going to be giving up so many points, and you need to know it really well, because they will ask you easy questions, medium questions, and even hard questions that deal with that. Let's look at number 5. For the function f defined above, what is the value of f of -1? So when they ask us f of -1, they are asking you, what is y equal to when x equals -1? So we need to plug in the -1 for x and then find that in our calculator. So we would have -1 plus 3 over 2. There's a little trick that you can use in your calculator. There's actually 2 tricks for function questions that I'm going to show you really quickly here. So we could totally do that without using a calculator, and I wouldn't judge you if you did. I'd say that's fine. You don't need to. Or I could put -1 in my calculator and then store that. So I'm pressing the store button as x, and then I'm just going to put in that function. So I have x plus 3 divided by 2. And that gives me 1. So my answer here is C. I can also solve function questions by graphing. So I can go to y equals, and we can graph x. Let me use my parentheses. Always remember parentheses on the calculator section. X plus 3 divided by 2, and we're going to graph it. And then I'm just going to go to my table, so second table, and see what is y equal to when x is -1, and when x is -1, y equals 1. If I have a really complicated function question, so it's a really long function, it's a big expression, I am most likely going to opt to just graph the function and use the table instead of solving it by using math. Because if I am adding -1 plus 3, I'm like, okay, that is 2 divided by 2, and that equals 1. But let's say this problem was like 3 times as long. The more steps I have to go through, the more mathematical operations I have to perform, the more likely I am to make a silly mistake. So if you do have a calculator and you're able to go into your calculator to solve some of these, you can kind of just give your brain a little break. Okay, let's look at number 6 here. Which of the following is equivalent to 2x times x squared minus 3x? So we know we need to distribute this 2x. I like on the SAT, whenever I have factors or I'm distributing, to do the last term first. So I am likely to first see, hey, what is 2x times -3x? And that gives me -6x squared, and boom, that is right there. So it has to be D. A lot of the time on the SAT, if you start with the constant term or the last term when you are distributing, that is what actually narrows it down to just one answer. If we first distributed the 2x to the x squared, put that in yellow here. If I first did 2x times x squared, I would have had to pick between both C and D. So it's just a little hack to first start with the last term. Let's see some other good ones in this test that I particularly want to go over. Let's look at number 23. So we have a table here, and then it says some values of x and their corresponding values of y are shown in the table above, where a is a constant. If there is a linear relationship, so you should have little alarm bells ringing in your head, that is y equals mx plus b, or ax plus by equals c. Either way is linear between x and y. Which of the following equations represents the relationship? And all of these answer choices are in standard form. Ax plus by equals c. So we somehow need to use that table to find the slope and then find the equation of the line and then put that equation of the line back in a standard form. That is a ton of work. And if I can ever bypass doing a ton of work on an SAT math problem, I 100% am. So instead of using the slope and finding change in y over change in x, and then using y minus y1 equals m times x minus x1, which would take a lot of time. And remember, the more steps you include, the more likely it is for you to make a silly mistake. I'm going to look at my table if there's anything nice for me to use. And I'm always looking in tables for zeros. That's my favorite thing to find. My second favorite would be multiples of 10. In this case, I have a 0 right here. When x equals a, y equals 0. So at this point, I'm kind of mentally ignoring the rest of the table. I'm just going to scratch it out so that you're not distracted by it. And I'm just thinking, hey, when y equals 0, x equals a. So I am going to make all of these y's 0, like so. And check which one of these would be true. So when y is 0, x has to be equal to just a. And that only occurs for answer choice A. We want to be critical thinkers on the SAT, right? We do not want to dive in and just start doing a lot of work without pausing first. And sometimes it's just a brief pause, but you want to pause a little bit and think, this is the SAT. They reward critical thinking. Is there maybe something that I can do here that does not involve a lot of work? Let's look at question 26 here. Keith modeled the growth over several hundred years of a tree population by estimating the number of trees, pollen grains per square centimeter that were deposited each year within layers of a lake sediment. He estimated there were 310 pollen grains the first year, so that's our starting amount. The grains were deposited with a 1% annual increase in the number of grains per square centimeter thereafter. Which of the following functions models PT, the number of pollen grains per square centimeter T years after the first year the grains were deposited? Wow, that's a mouthful. But we have a really important part here. It said 1% annual increase, and this is a core concept. Whenever I see percent increase, let's look at this here. So increased by X%, I am going to take that percent and express it as a decimal and add it to the number 1. So we are going to go back here and I'm going to say 1 plus 0.01, and that gives me 1.01. So I need 1.01 in my answer choice. So it cannot be A and it cannot be C. And I need to figure out, is my 1.01 an exponent as in B, or is it D? Is it the base? Who knows if it's B or D? Let me know in the chat. So Sydney says D, and that is correct. And Catherine also says D. We want the rate, or our percent increase, our growth rate, to be the base of the exponent. If you're in doubt and you're mathematically inclined and you're just not sure, try just picking a number for the first year. So for 1 year, for instance, remember whenever you see a variable or a constant in the answer choices, that's a clue that you could just pick a number. So after the first year, we should have 100% of the 310 pollen grains, right? Plus 1% of it. So I'm just going to do it with my calculator here. Let's see. So I'm going to do 0.01 times 310. So this is what I put into my calculator. I said 0.01 times 310 gives me 3.1. So after the first year, I'm going to have 3.1 more pollen grains added to that original 310. So I'm going to have 310 plus 3.1, and that gives me 313.1. And I can then plug in my 1 for T for 1 year and answer choices B and D. Let me show you what that looks like. Oops, there we go. So I am just going to try B first. I'm going to say 310 to 1.01 times 1. And that gives me 328. That's way more pollen grains than I actually have after the first year. And let's try out answer choice D. And that is 310 times 1.01 to the first power. 313.1, which is exactly what we found. So even if you're not sure, hey, should this be the base or should this be the exponent, we could still figure it out, just knowing that we need that 1.01. This concept appears all the time on the SAT. I highly recommend that you get comfy with it before you take the SAT later this year or next year. Let's look at number 28. It's another kind of graphing question, but we're going to solve this without using our graphing calculator. But remember that technically you could still just graph this on the calculator because this is in the calculator section, and we could just pick a number for K. We could say K is 2, for instance. So we could graph x plus 3 times x minus 2, and then match up that graph to one of the answer choices. Or we could use our core concepts and see that our leading coefficient here is positive. So it's a happy parabola. It opens up, it's smiling, it's very happy. So it cannot be A or B. And that parabola is written in the x-intercept form. So if we have a factor that's x plus 3, it means that we have an x-intercept that's equal to -3. So we can check these. Let's see, here we have -1, -2, so it can't be C. And here we have -1, -2, -3, so it's D. So even though some questions you can solve in the graphing calculator, it's through practice, and I strongly recommend that you go through all 10 practice tests at a minimum from the College Board. It's through that practice that you start kind of getting that judgment of, you know, this is a question that's worth it to put into my calculator. It's going to save me some mental energy. This is a question I need to put into my calculator because I don't remember how to answer it. Or this is a question that I should just answer quickly on paper. I'm going to be so much faster answering this on my own than if I plugged it into a calculator. Let's look at number 35. Which is a little bit more advanced of a question. And this deals with a concept that is tested on the SAT all the time. It's tested in different ways, but it's a very frequently tested concept. So you want to pay attention to this. In the equation above, A and B are constants. If the equation has infinitely many solutions for X, what is the value of B? So infinitely many solutions is a buzz phrase on the SAT, and it's also a core concept. If we look at our back page here of the core concepts, it says infinite solutions means it's the same line. So we have the same y-intercept and the same slope. So if I go back here, I know that I have the same line, same y-intercept, and then the same slope. And I hope that you recognize that that 4x plus 10 looks an awful lot like mx plus b. So we want to make the two sides of the equal sign look the same. So we could do this one of two ways. Method one would be to just factor that 4x plus 10 to look like the a times x plus b. So we're going to factor out a 4, and then multiply that by x. And then I need to think 4 times what gives me 10. I like to sometimes think about numbers in terms of money. It makes it easier to do simple math. If I think I have $10 that I need to split between 4 friends, if I only had 2 friends, they would each get $5. But because I have 4 friends, they each only get $2.50. So this would be 2.5. 4 times 2.5 gives me 10. So my B is 2.5, and I'm done. That's the fastest way to answer this question. Second fastest way is to multiply to distribute each side. So we're going to have AX plus AB equals 4x plus 10. And then we're going to see that they have to have the same slope. So if I look here, my slope on the right-hand side is 4. So that means my A also needs to be 4 because they have the same slope. So I would have 4x plus 4b equals 4x plus 10. They also have the same y-intercept. So I can go and grab that 10, that y-intercept, and say that has to equal 4b. And then say that 4b equals 10. So b equals 10 divided by 4, or 5 divided by 2, or 2.5. You could grid in either 2.5 or 5 over 2. Either answer choice there works, and you would get credit for both of them. Doesn't matter which way you do it. Let's look at another kind of trickier question for the calculator section, but we're not going to use a calculator. Number 34 here. The relationship between x and y can be written as y equals mx, where m is a constant. If y equals 17 when x equals a, what is the value of y when x equals 2a? I don't know about you, but by the time I'm done reading that question, my head kind of hurts. I'm like, wait, what? Y equals 17 and X equals A, and now X equals 2A. So we have to organize our thoughts so it doesn't get overwhelming. So I'm going to start by just writing my given equation here. Hey, Y equals MX, right? That's the first one they give us. And then they say if Y equals 17, right over here, if Y equals 17, so I'm going to make my Y 17, like so. So if Y equals 17, when X equals A, so let's plug that in. So we have M times A because X equals A, right? So we have 17 equals MA. What is the value of Y when X equals 2A? So what equals M times 2A? Well, remember way back when you first started learning math in algebra, was one of the primary principles you learned. Whatever you do on the left-hand side of the equation, you have to do on the right-hand side of the equation, right? So if I add 2 on the left, I have to add 2 on the right. If I subtract, I have to subtract on both sides. If I divide, I have to divide on both sides. If I multiply, I have to multiply on both sides. So I just multiplied that A by 2. I can't just randomly go and do that. If I multiply my A by 2, think about it. I'm going to make my A a nice bright red here so you can clearly see it. If I multiply that by 2, I have to multiply the 17 by 2 also. I have to do the same thing to both sides. So I have 2 times 17, or 34, equals M times 2A. We'll just put a little multiplication symbol in there. So what is the value of Y when X equals 2A? Well, it is just 34. That's it. You could get really tricky with this question. There are many ways to overcomplicate it and still get to the right answer, which is kind of surprising because usually when you overcomplicate a question, you're going to get it wrong. But it's a really good idea to think back to the basic math principles you've learned, even when you are kind of thrown with information that's overwhelming and seems really complicated. All they were really testing you on here is, do you know that you need to multiply the left hand of the equation by 2 when you multiply the right hand side of the equation by 2? Okay, let's see here. Does anyone have any questions before we wrap up today? Any specific questions in this math section, and you can scroll through it and see if there's one that maybe you're like, I was really hoping she would look at that one today, and maybe I didn't. I have time to go over a question if there's one that you would like to go over before we wrap up today. I did include the solutions to this whole section in the email that I sent out, and I will include it in the follow-up email too. And Maria, I did send out the core concept, so just check your inbox for that. If you still don't see it there, please send me an email and I will reply to that email with the core concepts. That goes for everyone. So if you missed the email or you haven't gotten it yet, just send me an email and then it's easier for me to respond to it. That's the best way. Okay, so Catherine asks for number 30. Let's see what number 30 is. So this is a little bit more of an advanced math question because it deals with trig. And the way that I can tell, it's probably going to deal with trig, and right here it doesn't show up, but this is parallel, is because they want to know the measure of an angle, and they don't give me any angles, right? So whenever we have that kind of scenario, we're probably going to need to use trigonometry or SOHCAHTOA. On the SAT, if you are given a shape that is unfamiliar to you, you should 100% break it up into shapes that you know well. In this case, I don't even know what the shape is called, but if I just draw a little dotted line down here, I can see I have a triangle and then a rectangle or a square, whatever that is. Depends how nicely you drew your line down there. So I now have a right triangle right over there. And they tell me that CD equals a half AB. So I'm gonna call CD X and nope, actually CD equals a half AB. So I'm gonna call AB X and I'm gonna call CD 1/2 X. How about that? Because CD equals a half AB. And then I'm gonna say that this is also a half X because those two lines, BC and AD, are parallel. So I can assume that that line that I drew right here is the same length as that line. There is no disclaimer there that the figure is not drawn to scale. So we can assume that what we're seeing is accurate. So I'm gonna say that cosine of theta, or this angle right here, we're gonna call theta, equals 0.5x or half x over x. And our x's are going to cancel, and we're gonna have cosine of theta equals 0.5. And in our calculator, we're gonna say that theta equals cosine to the -1 times cosine to the -1 of 0.5. And it's going to look like so in the calculator. First, I need to make sure that my calculator is in degrees. So I'm going to press mode and go down to degrees, make sure that's highlighted. And then I'm going to press second cosine and then put in 0.5. And it's going to give me 60. So theta equals 60. Theta is just a way to say an angle. My angle is 60 degrees. So I can put 60 degrees right here, but remember they want the whole angle B. So I need to add that right angle to the 60 degrees. So we have theta equals 60 degrees. So angle B is going to equal 60 degrees plus 90 degrees. A right angle is equal to 90 degrees, which equals 150 degrees, which is answer choice A right there. I don't see any other questions for today. If you have time, I would really appreciate it if you filled out the course evaluation on my website. It really helps me plan future courses and workshops and classes with the library. So let me grab that link. Oops. And I will share it. Where is it? In the chat box. Why isn't it coming up? Maybe it's not working right now. Let's see here. There we go. I found the link. So I'm sharing that in the chat box. If you would be so kind and just fill it out. It is 100% anonymous. And I really enjoy reading your feedback and looking at it when I plan future workshops. You are so welcome. I hope that everyone learned at least one thing. Even learning one thing is a great thing when you're prepping for the SAT. Remember that you can find all of these materials on the College Board's website. So you can find all 10 practice tests. The core concepts are my own design. So either reach out to me or check your email. I did send them earlier today. So most of you should have gotten them. I'm going to upload the recording of the session to YouTube if you want to catch up and rewatch it or look at it later. And let me see here. The SAT Bootcamp is a great place for you to start your SAT prep. If you don't know how to use your calculator well, or you're iffy on any section, it's a 3-hour-long bootcamp. It's free, it's on YouTube. You can watch it in different parts over the course of several days, and it's paired with the core concepts handout. I really explain each part of it. and it is the foundation for prepping for the SAT. So if there's one thing that you do before you take the SAT, I would recommend that you watch that and that you memorize all the core concepts. I hope that I'll see some of you back here for the workshops coming up. There's a reading one and a writing and language one if you haven't signed up for those yet. Okay, I'm gonna sign off. I will see you guys next time. Bye-bye.